Hello, Intrepid Explorer. You are the lucky recipient of an experimental MycoKit. Have a look at this video for an overview of a process for deploying your MycoKit in support of reliable mycelium-based distributed bioproduction. Tread heavily and press onward into the unknown. Your humble node in the mycelium movement, Rolando. The first thing you'll want to do is take an inventory of your MycoKit. You should have received in the mail. What you'll find inside of your Pringles container is some cheesecloth, a tissue coring tool, and 4 plates that contain 4 different sequenced filamentous wood-eating fungi. So go ahead and take an inventory and make sure you have everything that you see here. Keep in mind that this is a suggested protocol, and what you decide to do, whatever best works for you, may be different. The first thing you'll do is prepare the substrate for aqueous extraction, and to do that you'll start by weighing out some Pringles. Next, you'll grind up your substrate, your Pringles, in a blender, or as we do in the ND lab, in a magic bullet. They work very well and they're very cheap, but you'll typically let this go for about a minute or until the substrate is completely pulverized. After you've pulverized your substrate, you'll then attempt to collect as much of it as you can into a beaker or some other container, where you'll add water and then perform an aqueous extraction. The way we do it in the ND lab is using autoclave by adding the water into the beaker with the substrate and autoclaving for 45 minutes at a 121 C. You'll then prepare your filtration system. You'll start by cutting some parafilm to wrap around the vacuum flask or the container you'll use to make it seat such that it's airtight and you can create a vacuum. You'll use that parafilm to wrap around the funnel so that you can create an airtight seal between the funnel and the flask when you apply the vacuum. We typically use a few layers of parafilm to ensure that we get good coverage of the funnel and that we get a good connection with the flask and an airtight seal. Next, you'll cut some cheesecloth if you need extra. You'll likely need more than what we were able to send you in your kit, and you'll use that to help you filter out the particulates from the aqueous extraction. You'll want to fold the cheesecloth so that you can position it properly inside of the funnel to allow you to apply vacuum but allow air to flow through the funnel still, so that when you pour the aqueous this extract onto the funnel with the cheesecloth inside, it will then filter out the particulate, allowing the nutrient broth to go through. After assembling your filtration system, you move on to preparing your agar and your bottles for adding in your nutrient broth so that you can make plates. So we typically use Bacto agar. You will weigh a bit of agar out and then add that to some clean empty bottles, and then wait for your aqueous extract to finish cooking. Once your aqueous extraction is complete, you'll move on to filtering out the particulate from the broth. You'll use your filtration system and some of the cheesecloth, either the cheesecloth we provided or additional that you may have acquired, and you'll use a piece of cheesecloth over your container to capture some of the particulate in the container, and that helps with maintaining flow in the funnel. After you've applied vacuum, it tends to get clogged. If it does become clogged, there are a few strategies, and we'll share those with you. Once you've filtered out most of the broth, you then measure out the necessary quantities that you need to add to your agar using typically a graduated cylinder. Now, if when you're filtering out the particulate from the broth, you find that your flask or your funnel becomes clogged, you'll then just remove your cheesecloth from the funnel and add in a new piece. Once you've set up your new flask, funnel, and beaker with your cheesecloth, filter out the rest of the particulate and capturing as much of the broth as you can. You then add the specified quantity to some agar in a bottle, and then it goes in the autoclave for sterilization. After you've sterilized your broth agar mix, you're ready to pour plates and start tissue culture. When plugging your plates, you'll want to observe sterile technique, and this also includes sterilizing your spatula and your tissue coring tool, and that includes in between working with different fungus so that you don't contaminate one fungus with the other. Do take care when flaming your tissue coring tool to not melt it too much. If it does, have no fear. general rule with tissue culture for fungi is that you want to take a plug from the leading edge of the colony, and so we use our tissue coring tool and we take as many plugs as we can from the leading edge of each colony. Don't be shy when you cut out your plugs. Just cut out as many as you can. You never know how many plugs you're going to need. You might drop a couple, so it's always good to cut out a few extra. And plus, you can always subculture and grow some more fungus. We typically use a spatula to move plugs of tissue to new plates for subculture, and you want to be careful to make sure that the surface that the fungus is growing on, so the top surface of the plug, faces down onto the auger on the new plate. And we typically place the plug at the edge of one side of the plate so that it gives it a lot of real estate, gives the colony plenty of real estate to grow. As I said, in between working with different fungi, you want to make sure that you sterilize your spatula and your tissue culture tool. Make sure that you don't cross-contaminate your fungi. Once you've plugged the last of your plates, you'll then collect your plates and incubate them at 30°C at 80% humidity. To achieve this, we typically place some soaked sponges inside of a beaker. We then take that beaker, we put it inside of an ice chest or some container. In our case, this container sits inside of a walk-in room that is maintained at 30 degrees Celsius. In this way, we can have culture at 30°C. Then every 24 hours, trace the leading edge of the colony. Repeat this for 5 days. When you're done tracing and you're finally ready to take the images, you'll want to set up a space that's pretty standardized so you can get the size of the images consistent across days. And you'll want to make sure that you're considering things like glare. But basically, the images don't have to be the best, but we would prefer the images to be taken at about the same distance from the plate and preferably with all of the colonies visible, such that when you email us the images, it'll be easier for us to extract the radial growth data. One difference in the images that you should expect is that your images will have the traces of the colony over the 5 days. Once you've taken the final image, then you're done, just about. Email us the images and then we will share the results with you, and then we can all move forward with the next step in contributing to the interlab study of reliable, distributed, mycelium-based bioproduction. And with that, on behalf of the MD Lab and the mycelium movement, thank you for your hard work and your contributions. Until next time.